Hi there, folks. In this lesson, we're looking at finding zeros of polynomial functions. And there's a couple approaches to this. One is going to involve us kind of searching for answers to kind of get us going. Sometimes we'll have to use synthetic division to kind of break this thing down into a partially factored form, and then continue to factor it. Sometimes we can factor it as is, and we've kind of already looked at some of those. So always check, see if you can factor it completely first. If you can't, then we want to use the information given to use some synthetic division or even long division if we have to, in order to break this thing down further to get it to a point where we can continue to factor it and then solve by factoring to get all the solutions. So, for example, if I look at something like this first guy, right away, on something like this, you might try, factoring by grouping first, by putting the first two together and the second two terms together. Because you see four terms, factoring by grouping makes sense. But what's going to happen here is you're going to find out that factoring by grouping doesn't work for this one, okay? And so now we have to go to something else. We have to break this thing down using some division first and factor by division in order to get all of the solutions. And notice it gives me one of these. It says f of negative 6 equals 0. Essentially, that's saying that x equals negative 6 is one of our answers, which means, again, think backwards, that x plus 6 must be one of my factors. See, x plus 6 equals 0 would give me that solution of x equals negative 6, okay? So once again, I'm going to factor by division here. So I'm going to divide this by an x plus 6. And that's going to allow me to kind of create this factored form, okay? And so here I'm going to have x plus 6 times, well, let's divide out that x plus 6 and see what I get. I can use synthetic division, so I put the negative 6 in the box, and I write down my coefficients. And now this is a big addition problem. I bring the 3 down, I multiply, I add straight down, I multiply, I add straight down, and I multiply, and I add straight down. And once again, because I already know that negative 6 is one of the solutions, of course I should get a 0 when I do my division. If I don't, there's a problem somewhere, okay? But now I interpret this answer. Let's see, that's a 3x squared minus 4x minus 4. And so my factored form over here is this guy. And now I continue to factor this because the idea here is I want to solve. I want to set this thing equal to 0 here, and I want to solve by factoring. I have to continue to factor this thing. I've used some division to get a partially factored form. Now I can build a bridge, two numbers that multiply to a negative 12, but add to a negative 4, a negative 6, and a positive 2. And this is when I can't use my shortcut on. I have to split up the middle term and factor by grouping. So take that off to the side, split up the middle term, factor by grouping. I'm going to do it in my head. And I get this as the completely factored form, okay? And now, because the thing is completely factored, it's equal to 0, I just set each factor equal to 0. So I do x plus 6 equals 0, 3x plus 2 equals 0, and x minus 2 equals 0, and I solve each. Here I subtract the 6. Here I subtract the 2 and then divide by the 3. And then in this last one, I just add the 2. Okay? And so I get my 3 answers. And yeah, one of these answers was already given at the very start of this problem, but that's okay. Now I've found the rest of them, and I've stated all of the answers kind of together here, which is a nice way to do it. Okay? But again, that we started by getting this thing going using some division to help us get to the completely factored form. And then we just solve the way we've always solved. We set each factor equal to 0, okay? If I look at this one, it says find all the zeros of the function, given that x equals 4 is a 0. So once again, I want to set this thing equal to 0. I want to find all the values. And once again, 4 terms. I see 4 terms. I might try something like factoring by grouping. Again, it doesn't work for this particular example. And it's really easy to get the factoring going when you have one of the answers anyway. So again, if you think about this guy, if x equals 4 is a solution, then x minus 4 must be one of the factors. See that x equals 4, think about where that would have come from. X minus 4 equals 0, what gives us the x equals 4? So essentially, once again, I'm going to divide this out. I'm going to divide this guy by x minus 4. And I can use synthetic division to do that. So take it off to the side. I put the 4 in the box, and I write down my coefficients. And once again, I bring this guy down. That's a 2. I multiply, and I add straight down. I multiply, and I add straight down, and I multiply, and I add straight down. And once again, I shouldn't be shocked by the 0. I expect the 0. If I don't get a 0, something's wrong. Something's gone funny here. And now I interpret this answer. That's a 2x squared plus 11x plus 5. And so now I can write my factored form. I divided out the x minus 4. So essentially, I factored out the x minus 4. And when I factored out the x minus 4, it left me with a 2x squared plus 11x plus 5. And again, I want to set this equal to 0. I want to find all the solutions. I continue to factor. I can factor this trinomial by building a bridge. I build a bridge, two numbers that multiply to a 10 but add to an 11, or a 10 and a 1. And once again, I can't use my shortcut for this one, so I got to take it off to the side, split up the middle term, factor by grouping. I'm going to go ahead and do that in my head. I'm very confident that you can all factor by grouping at this point. That's going to be a 2x plus 1 and an x plus 5. Okay, and now once again, I set each factor equal to 0, because this is how I solve. I get the factored form equal to 0. That means I could set each factor equal to 0. And here I add the 4. Here I'm going to subtract the 1 and then divide by the 2. And here I'm going to subtract the 5. So here's my 3 answers. And once again, I had one of those answers already, and that's okay. But now I've gotten the rest using that answer to help me factor. Okay? If I look at this one, this time none of the answers are actually given. And so it says find all the zeros of the function, but we don't have any zeros to start with. And so as we look at this thing, yeah, maybe I try factoring by grouping again because I see 4 terms. That's not going to happen. It's not going to work. And it gives me a hint here. It says guess. Let's just guess. Let's just take some guesses at what the possible answers could be. And here's the thing. Guessing isn't too bad here because we have synthetic division. The guesses go really quickly. And we can narrow down where we get these guesses. There's this theorem that basically says that all the rational roots of this thing, so all the rational answers, come from factors of A and C, essentially, okay? And so when we kind of look at this, and there's different ways you can approach how we come up with those factors. But here's what I do. I build a bridge and then divide each of those factors by the leading coefficient. So here's the fast, easy way to kind of get all the possibilities for your guesses is we build a bridge. That was a terrible bridge. I missed. Let me try again. I can do better right there. Okay, so 1 times 30 is a 30. And essentially, I don't say, hey, I want to multiply to 30, but add to this or whatever. I just break this down and say, okay, what are the factors of 30? 1 and 30, 2 and 15, 3 and 10, 5 and 6. And I think that's kind of it there. But then keep in mind, I could also have negative versions to each of these, right? Because couldn't I have a negative and a negative here? And so the idea here is I could have plus or minus for any one of these, okay? And you're probably looking at this thing going, that's not a real narrowed down list there, Mr. Jansen. And you're right, it's not. But now this still isn't my list. I have to divide each of these by the leading coefficient, which is a 1. And so for this one, that doesn't change anything. But if that was a 2, well, then I'd have instead of a 1 here, I'd have a plus or minus 1/2. Instead of a 30 here, I'd have a plus or minus 15. So we divide each of those factors by leading coefficient. In this particular example, yeah, I don't have to worry about that because there's a 1 out front, okay? And so from here, I want to take a stab at this. I just want to take a guess. And the idea is there are some guesses that are better than others, okay? When you think about the nature of synthetic division, okay? Let me take a really poor guess for a moment. Let me write down the coefficients. But we can tell right away there's something like 30 would not be a good guess. Don't even bother writing this down. Because right away, I can tell that 30 is going to be too big. I can tell that because I understand with synthetic division, I'm bringing this down and I'm multiplying by that thing. Well, there's a 30. And all of a sudden, now I've got a 24. Now I have to do 30 times 24. I don't think I'm going to get back down to a 0 by the time I get to this last guy, okay? And so when we're looking at these guesses, we kind of have to look at this and say, all right, number sense becomes important here. 30, as I start to multiply, it's going to get out of control. It's going to get too big, okay? I'm looking for something that's more middle of the road, and I notice that I want to end over here. In order to get a 0 over here, in order to get a 0 here, I'm going to need a negative 30 at this slot, okay? So I need something that's big enough to get me to the 30, but not too big, okay? And so maybe I guess it's something like, I don't know, a 5 or something like that, or maybe a negative 5. We'll see how it goes, okay? So we guess it's something like a 5. Maybe I guess something that's a little bit more middle of the road, or better yet, I think I'm going to go with something safe like a 3, okay? And again, watch how quick it is to check these. Ready? 1, multiply, bring that guy down, multiply, bring that guy down, multiply. I nailed it. I'm so glad I switched to the 3, right? Well, here's the thing. The 5 might have worked too, okay? I don't know what the rest of these factors are. And so here's what's happened. I took a guess and I got it right on the first try because I'm amazing. I'm such a good guesser. It's a real skill that I have, all right? But here's the thing. That guess and check that I just went through took me all of 10 seconds using synthetic division. Synthetic division is fast and easy, and that's kind of the point, okay? So even with like 5 guesses in, I'm going to be less than a minute into this problem, okay? And hopefully it doesn't take me 5 guesses to get this thing. So now I have to interpret this. Ready? This, if x equals 3, that means I had the factor. What I was dividing out was an x minus 3, okay? And what it left me with was an x squared minus 3x minus 10. And so, again, I want to factor this thing. So think about what the factored form is. It's an x minus 3. That's what I divided out. And it left me with an x squared minus 3x minus 10. Okay? And so now I set this thing equal to 0. And now I continue to factor. Ready? Right here, I build a bridge. 2 numbers that multiply to a negative 10 but add to a negative 3. This is a quadratic, so I can get to the factored form here. Well, that's going to be an x minus 5 and an x plus 2. And so the 5 wasn't a bad guess. That one would have worked too, because x minus 5 would give me an x value of 5. Okay? Now I'm sad that I abandoned it. I should have gone with my first instinct there. Okay? But now I have this thing factored completely. Okay? And now I set each factor equal to 0. And you know, sometimes you'll guess right on the first try, and sometimes you won't, and that's okay. I won't guess right on the first try every time. I just happen to guess both of the correct answers this time, which is, you know, pretty amazing. Pretty amazing when you think about it. Okay? But again, you're not always going to guess right, and that's okay. All right? The point is that with synthetic division, taking a bad guess, it's not that bad. All right? It doesn't take you that much time. Synthetic division is fast and easy. Okay? The other piece of this thing as we go to continue to solve more of these is the idea of the fundamental theorem of algebra. The fundamental theorem of algebra is basically, if we look at the degree of the polynomial, if the degree is n, well, that's how many solutions there would be. Now, keep in mind that includes multiplicity, and you might have heard that word before, okay? But multiplicity means like repeats, okay? So when it says there are, you know, if it's a 5th degree, there's 5 answers, well, all 5 of those answers could be the same answer. I could get the same answer 5 times, okay? But the fundamental theorem of algebra just means, hey, you should get that many answers. And so it's a nice way to check just to say, hey, did I get the right number of answers, okay? But keep in mind, that includes irrational roots. It includes complex roots, so imaginary stuff, okay? But it also includes if values are repeated, okay? When you think about like a quadratic, go back to a simple example. Sometimes quadratics, we only got one answer, but when we solved, we would get that same answer twice, okay? And a quadratic, we should always get 2 answers, even though it was the same answer twice, okay? So that idea of I should be able to count and see how many factors, how many solutions I get, okay? And so if I kind of apply that to this one, I'm going to do the same thing I did in the previous problem. I'm still going to do a little guess and check, and I'm going to find the solutions. I'm going to factor this thing by division, that kind of stuff. But I'm going to count up my answers at the end and say, hey, I should get this many because of the degree. And so when I look at this particular example, this is a 5th degree, which means I'm looking for 5 answers, okay? So 5 solutions. right? Now, granted, again, that includes if I get the same answer more than once, okay? That would count as 2, all right? And so as I look at this one, once again, I could build a bridge. I could start checking for certain factors, but I could also look at this and say, hey, there's 4 terms. Maybe you want to try something like factor by grouping, okay? I know a lot of times when we try that, sometimes it doesn't work, but sometimes it does. So, always test it. So here I'd take out the x cubed. That's an x squared minus 4. Here I can take out a negative 8, which leaves me with an x squared minus 4. And look at that. This one is going to be able to solve by factoring. I can use factoring by grouping on this one, so I don't have to guess and check this time. Okay. So now I've got x squared minus 4. I've got an x cubed minus 8. And now each of these is a special case. This is an x plus 2 and an x minus 2. Because that's a difference of squares. The second one here, the second binomial that I have written down, that is a difference of cubes. That's one of my SOAP problems. Remember, binomial and a trinomial. I fill in the signs. SOAP, same, opposite, always a plus. This is an x minus 2 because it's like the cube root of each of those values. And then the first term squared goes here. The second term squared goes here. Multiply the 2. 2 times x goes here. Okay, and again, that's the one students hate because it's all memorization, all right? Sum or difference of cubes is pure memorization in terms of where you plug these things in, okay? And now I set each factor equal to 0. Ready? X plus 2 equals 0. X minus 2 equals 0. Another x minus 2 equals 0. And then an x squared plus 2x plus 4 equals 0. And I solve each. This one I subtract the 2. This one I add 2. This one I add 2. And then this one, remember a quadratic, I would solve typically by factoring, but this one can't be factored. Build a bridge. There's no 2 numbers that multiply to a 4 but add to a 2. That's crazy talk. So that means I have to go to one of my other methods, either completing the square or the quadratic formula. Let me take it off to the side here. Me personally, I'm going to do completing the square on this one because I have a b value that's an a value that's 1 and a b value that's even. So I'm going to subtract the 4. You can absolutely do the quadratic formula on this one, and that would be fine, just fine. B divided by 2 and square it, that's a plus 1. This factors into an x plus 1 squared. I take the square root of each side. That's going to be plus or minus I root 3. And now I subtract the 1. And so let me bring it back over here. X equals, that's going to be a negative 1 plus or minus I root 3. Okay? But now, quick check. Let's count up the answers I got. Ready? 1, 2, 3. Oh, I guess I could label them with actual numbers. I was like tallying them off here. Ready? How about this? Ready? 1, 2, 2, 3, and then this is 4 and 5 because the plus or minus means 2 things. And so the idea here is if this is a 5th degree, I should get 5 answers. Now, granted, 2 of those answers are the same. 2 of those are repeats, but part of that theorem is we have to count the repeats. If I were actually just writing the answer, I would probably just list that once. I would say negative 2. Actually, I'd probably say it's like plus or minus 2, and then negative 1 plus or minus I root 3, okay? To write it in a little bit of a more succinct manner, okay? If I look at this one, something like this guy, maybe you try something like factoring by grouping. I see 4 terms. I try factoring by grouping. Spoiler alert, it's not going to work this time, okay? So this one, I'm going to have to do a little bit of guess and check, okay? So here it is. I build a bridge. Ready? I build a bridge. That's an 18. Let me write out the factors of 18. 18 times 1, 9 times 2, 6 times 3, and I think that's it. And each of those could be a plus or a minus, okay? But now those are not my guesses. I have to divide each of those by a. Well, this time I have an a value of 2, which makes a difference. So here's my list of guesses. Ready? If I divide each of those by 2, that 18 becomes a plus or minus 9. That 1 becomes a plus or minus 1/2 would be a good guess. Okay? The 9 becomes a plus or minus 9/2. The 2 becomes a plus or minus 1. The 6 becomes a plus or minus 3. And the 3 becomes a plus or minus 3/2. Okay? Any rational answers that I would get would come off of this list. Okay? And so from here, I just have to start guessing. And most of the time, students, will tend to avoid the extremes. Like we'd probably avoid that 9 unless I had some pretty big values here. The other thing that you should notice right away is all of these are positives. Okay, that's significant. Again, we're thinking about number sense, and we're thinking about the fact that I'm going to put something in this box, and it's going to be 2, 3, 24, 9. Let me use an example here, something simple like a 1. Don't even try this. The 1 is not going to work. I mean, we can tell it's not going to work right away. This is an addition problem, and watch what's happening here. Oh, 15. But you see, how am I going to get a 0? Okay, right away, I don't even finish this problem, and I can already tell it's not going to work. Okay, because I'm adding here, I need to get a -9 by the time I get to the end. That's not possible right now because I don't have any negatives. All right, which means right away, I know my answer has to be negative. Okay, so think about that for a moment. That really narrows this down. Here, let me erase all these plus signs. There you go. I just cut the available answers in half. Okay. And so instead of having all those different versions, now I only have the negative versions, okay? Students also like to tend to start with, values that are easy. In other words, not fractions. Let's avoid the fractions. So maybe I'll try the -3 or the -1, something like that, okay? Let's try the -3. Why not? So I bring that guy down. I multiply, and I add straight down. And I multiply, and I add straight down. And I multiply, and of course I add straight down, and lo and behold, I guess I made an amazing guess. But keep in mind, I did have a wrong guess before this. It was I knew it was going to be wrong before I started, but that's besides the point. Okay, and so we've got a right answer here, and maybe one of those other ones would have worked. It depends on how many rational answers we have. But here's the interpretation: if x equals -3 is an answer, that means x plus 3 is one of our factors, okay? So we have to work backwards to the factor. That's what I divided out. And so if I think about the factored form, it's an x plus 3. And then the other guy here is a 2x squared plus 7x plus 3. Okay? And now I want to set this whole thing equal to 0. I want to continue to solve by factoring. So here we go, build a bridge. Two numbers that multiply, and again, I'm kind of starting over. Ignore all that other stuff I just did. Multiply to a +6, but I'd add to a +7 or a 6 and a 1. And because there's not a 1 out front, I have to take this off to the side. I got to split up the middle term, factor by grouping. So go ahead, do your factoring off to the side. I'm going to go ahead and do it in my head again. 2x plus 1 and an x plus 3. And look at that. Now we see what a great guess my -3 was, because that's the only nice answer from that list that I would have been able to get. The other one's going to be a fraction, as I set each of these equal to 0. And so here I get x equals a -3. Here I get x equals, I subtract the 1, divide by the 2, so a -1/2. And here I get x equals a -3. But notice, even the -1/2, that's on my list of guesses. Any rational answer I get should be in that list of guesses that I had, okay? And that's what's nice about that list, okay? All the rational answers will be included there, okay? And so once again, count them up. I had a third-degree polynomial here, and look at this. I got 1, 2, 3 responses. Yeah, 2 of them are the same, but that's part of the theorem, okay? When we're counting up those number of responses in conjunction with or comparing to the degree, we have to count those duplicates. But now, of course, when I write my answer, I'd probably just say, hey, x equals a -3 and a -1/2. There's my two answers without writing the duplicates, okay?